Hello, good morning, good afternoon, depending on where you are. I'm Nafomon Sogoba from the Malaria Research and Training Center, the University of Bamako. My talk will be about malaria vector control in high seasonal malaria transmission setting in Mali, challenges and opportunities. The malaria vector control strategies recommended by WHO are the use of long-lasting net and universal coverage, the implementation of indoor residual spraying, and also larval control. But for larval control, this is very difficult to be implemented in Africa because of the natural condition. In Mali, we have also some areas, in addition of the long-lasting net, we have the indoor residual spraying together in the same area. So the use of these current vector control tools has significantly contributed to reduce malaria incidence in several African settings, including Mali. But as in Mali, we have different ecological zones with different intensity of transmission. The question is which tool is more effective and where, and what can be the long-term impact on of the use of these malaria control tools on malaria vector biting and arresting behavior, and what are the current challenges associated with malaria vector control tools. Sedu have already presented the objective of our ICEMR project, and to remind you, it is to study the variability of effect of the current malaria control strategies in different epidemiological settings. My talk will be specifically focused on assessing seasonal changes in malaria transmission intensity in relation to current control tools, to assess effect of combined intervention or malaria transmission indicator, to determine prevalence of insecticide resistance mechanism in malaria vector, and to assess dry season survival strategy in relation to local environmental conditions in Mali. So here is the changes we can observe in the entomological transmission indicator in relation to the intervention. When we look at the beginning of our first ICEMR in 2012, we can see that we were having sometimes very high man-biting rate and also a relatively high entomological inoculation rate. But starting from 2015, with the implementation of long-lasting net at universal coverage, we can see that there was a decline in both malaria vector biting rate and entomological inoculation rate. Even we can observe year-to-year variation. Investigating mosquito biting behavior. In Mali, we choose two localities. One is in Savannah area along the Niger River, and one in the Sahelian area where we have right cropping. Here is in the Savannah area near the river Niger, and this is during the rainy season. We can see that normally malaria vector are known to be biting more indoors than outdoor. But here we can see that there is a change in the biting behavior from inside to outside, from 11 p.m. to 4 a.m. in the morning. During the dry season, we can see that it is there is more indoor biting during the dry season from 1 a.m. to 6 a.m. In the Sahelian area with rice cropping, we can see that during the rainy season, there is equal biting rate outdoor and indoor. But when we come to the dry season, we can see that there is a consistent higher biting rate outdoor compared to indoor, with a peak we can observe here about 11 a.m. Here we compare integrated intervention area with non-integrated intervention area to non-integrating intervention area. Here we have a long-lasting net universal coverage in addition of indoor residual spraying. And when we look on the pattern of the transmission, we can see that we have very low man-biting rate and undetectable transmission as measured by entomological inoculation rate. But in its neighbor area where we didn't have indoor residual spraying, we can see that we have high man-biting rates and relatively high entomological inoculation rate, with its seasonal peak observed here in September. And this has been published in a journal. Here we compare the area with long-lasting nets and indoor residual spraying during the implementation of the indoor residual spraying, and 2 years after stopping with the indoor residual spraying. And we can easily see that 2 years after, we see a rebound in both man-biting rate and also in entomological inoculation rate, with the seasonal peak again observed here in during the end of the rainy season. We investigated the susceptibility of malaria vector resistance to insecticide commonly used in vector control. And here is the insecticide resistance to pyrethroid, and we observe a very high resistance, phenotypic resistance to pyrethroid, and the investigation of the mechanism of resistance show the presence of the Cardiac East as well as the Cardiac West. In addition, for the first time, we observed the N15 and 70Y resistance mechanism in Mali. This was also published. We also assessed vector resistance to carbamate, and we can see that the AC1 mutation was also present in all malaria vector species in Mali, and the allelic frequencies were relatively very high in Anopheles gambiae vector and relatively low in Anopheles arabiensis vector species. The dry season malaria vector ecology investigation allow us to identify favorable and natural idle resting site within the riparian forest at the forest edge and its dense undergrowth. Anopheles gambiae were found to shift or adjust their resting site during the day according to the sun movement. Both Anopheles gambiae and Anopheles culusi species feed extensively on bird in isolated inhabited natural habitat, and sugar feeding sources through the dry season included flowering, invasive and ornamental or agricultural plant, honeydew, melon, etc., etc. We observe also a movement of mosquito from their refuge over the River Niger up to 1.2 kilometers, but young mosquito did not move much faster than 100 meters during the dry season. In summary, we can say that with the use of the current vector control strategies in Mali, which are the long-lasting net and indoor residual spraying, we observe a decline in entomological indicator of Plasmodium falciparum transmission, but this seems to also enhance outdoor biting behavior of malaria vector in different ecological settings, and also may have induced the multiple resistance mechanism in malaria vector in Mali. Integrating long-lasting net and indoor residual spraying significantly reduce entomological parameter of transmission. However, after stopping the indoor residual spraying, we observe a rebound in the transmission in the area. The malaria vector ecology investigation shows that malaria vector remain active in rice cropping area and also in the area nearby the Niger River, and mosquitoes are developing in the breeding site in the Niger River bed, and they have developed a sugar strategy, feeding and also resting and movement strategy along the river. So the challenges which are related to the current control strategies, I can give you here 3 of them, which are how to mitigate the insecticide resistance and how to control malaria vector in the natural like a river bed and man-made like irrigation, which constitute the residual transmission areas. How to address malaria control in this context. How also to address the outdoor biting and resting vector during the dry season. And lastly, how we can reduce the rebound effect in transmission after stopping intervention. Regarding the first challenge, the opportunity we can draw from this is a multi-sectoral approach, which include agriculture, health, environment, and all people who are involved in malaria vector control to better understand what are the contributors to insecticide resistance. To understand also the ecology of malaria vector during the dry season, so that we need to do this in natural as well as man-made residual transmission areas like the river bed and the irrigation areas. Also to elaborate focal control strategy with community engagement. One of these can be, why not implementing a dry season IRS along the Niger River, for instance. We need also to develop due control strategies which will target outdoor resting and sugar feeding vector during the dry season. An example is the ISTSB, which are actually being experimented in Mali, and preliminary results have shown that this strategy can contribute, in addition of the other control tool, to reduce by 30% the annual prevalence and incidence of malaria in the area. For the rebound effect, we need to advocate for sustainable funding and also promote the control of other strategies like ITPTT and also SMC. So I would like to thank all the investigators and collaborators who have contributed to this work, and I say thank you